Okay, hi guys, how are you? How you doing? Today we're back to our class, which is techniques of integration for calculus 2. We'll discuss in more details the techniques of integration. We'll practice more problem about integration by substitution. The class will be about 21 minutes today, 21 to 22 minutes. And if you have any question, just please text me the question, take a picture, text it to me to this phone number, or send an email to this. Then our class today is calculus 2, technique of integration, integration by substitution in class 4. Okay, and now we don't mind subscribe and like. Subscribe and like. Okay, this is the only class. Subscribe and like. Guys, let us solve a problem about this technique of integration. Okay. The first problem I have, integration from 0 to the 3, and we will do and remember when we were talking about integration by substitution, we said we're going to have two functions. One of them is the derivative of the second one. Look the bottom. The bottom is u. U equal e to the x plus e to the negative x. This is u. The first step to find which function is u. The function, if you derive it, you get the other. The function, if you derive it, you get the other. Just to refresh your memory, I'm going to use a different color here to refresh your memory, is to tell you how to find the derivative of the exponential function. In general, y equal e to the 5x, negative 5x, y prime equal negative 5, and you leave this guy alone. You leave it e to the negative 5x. You see what I did? Nothing changed. You derive the exponent. Now this is the case when the base, is e. How about when I have a different case? How about if I have a different case than what? How about if I have a different case, which is a different base, which is e. How about, like example, y equal 2 to the 5x. 2 to the 5x. 2 to the 5x. Now, how we derive it? Y prime equal. Look, two steps. The first step is to derive this 5. Then, leave 2 to the 5x. Because the base is 2, not e, we will multiply by ln. We multiply it by ln ln 2. Okay. Let us see what the derivative. Then here du equal integration of, derivative of e to the x is e to the x. Now what we have, negative negative e to the negative x. Why negative? Because we have negative 1. Derivative of negative x. Derivative of negative x is negative 1. And all this with dx. Now we're looking for dx. Dx equals du over e to the x, e to the negative x. Go back here. Now leave the limit. Leave the limit. Don't touch the limit. I will not add the limit. I have two choices, which I rather my way in solving this problem is to keep going without limits. Then when you bring back the x, and instead of you bring back your limit, which is this, and each teacher has his own way. I prefer this way. Okay, now this is e to the x, e to the negative x over u, and dx equal what? Dx equal du over e to the x minus e to the negative x d, right? Du. Okay. Now what happened here? All this guy, e to the x, dot e to the x, e to the x, and e to the negative x. This cancel with this. Left integration and du over u. Integration of du is very well known. Integration of du over integration of du over u. Everyone knows that ln u. Ln u. Then this equal ln u. Ln what? U. Now we're gonna bring u to here in this box. This equal u is what, guys? E to the x u. From this u equal e to the x, e negative x. Now the last step is to evaluate this integration from 0 to where? To 3. You see, we bring the limit back after we change u to the x. Now put 3 equal ln, start with the top value 3, e negative 3 minus ln e0, e negative 0 equal ln e to the 3, I will leave it, I will not touch it, and minus ln 2 minus ln 2. Okay. Why ln 2? Because e to the 0 equal 1 and e to the negative 0 is 1. That's it. E to the 0 and e to negative 0 is 1. Let me go to number 3. Okay, number 3. How we solve this? Look, you in this level of calculus, I said you have to be able to see something. You know what I mean? To see the problem very quick. Here I can distribute the denominator. Look, this equal ln x to the 8 over x plus 1 over x dx. I have two integration, which is this equal ln x to the 8 over x dx plus integration of 1 over x dx. Okay. Now, this two integration, this part is easy. This integration is easy integration. I just give you the rule in the top problem. This is this guy equal ln x. I like to use absolute value because the domain of the ln has to be positive. In this case here, ln u, look here, everything, u equal, I'm going to use integration by substitution, u equal Ln x, I'm gonna put here in this side. Okay, keep my u's here. Okay. And use different color for u. U equal ln x. Again, what the derivative of du? Du, derivative of ln 1 over x dx. Good job. Now solve for dx. X du equal dx. Then dx equal to, guys, dx equal x du. Okay, this, then let us back here. All ln x becomes u to the a. And this guy, x, okay, x is x. And dx is x du. What you notice, this cancel with this, and this equal u to the 9 over 9 plus c, right? But we have, don't forget this integration. U is how much? Ln x to the 9 over 9 plus ln x from that second integration plus c. Good job. Okay. Okay, let us go to that problem. And I meant to mix some definite and indefinite integration for you guys. Here this is easy, right guys? All what we have to take this guy equal to u. U equal negative 3x squared plus 8x. Then du is what, guys? Du equal negative 6x, right? Derive it. Right? Let us derive negative 3 times 2, negative 6x plus 8. Okay. Now I need you, this dx. I need you to look always, to keep your eyes open between the derivative negative 6 plus 8 and I have negative 3x plus 4. From before this equal, I can do 2 out, negative 3x plus 4 and dx. You see, to make it easy for me later on, this equal sign. Okay. Okay, now let us back to this guy. Leave the limit. I don't want to touch the limit. This guy, negative 3x plus 4. This guy becomes u. All this guy becomes u. And the dx is what, guys? What my dx? This is du. Dx equal du over 2 negative 3x plus 4. What I did, dx, we divide both sides by 2 negative 3x by 4. And bring this back here, du 2 negative 3x plus 4. This cancel with this. Right? Now what left? One of this one. I can't take the constant out. EU, du, half. Now integration of AU in different color. Integration of EAU, du, EAU over the derivative of the exponent plus c. Since I have e to the u only, then the integration e to the u. Now bring u as is. What u? U is negative 3x squared plus 8x. Now my limit from 0 to where? To the 2. Then the last step after you bring your limit. Now plug the limit. Start with the 2. Half e 4. 2 squared is 4. 4 times negative 3, negative 12 plus 16 is 4. Minus half, right? We're done with the 4, with the 2. 2 squared is 4, negative 3, negative 12, 16. Fix me, guys, if you have any question. E now 0, 0. and this is half e4 minus half, because e to the 0 equal to 1. Okay. Okay, now number 4. Number 4. Okay, I have two functions. Look, I'm going to circle my function. I can do this one and this one, right? This one and this one. Let us take u equal what? Look here, the big one, the one in parentheses usually. Okay. Okay, I have a rule. I'm gonna give it to you. Now you are in calculus 2. Y equal square root of f of x, to make it easy. Y equals square root of f of x. Y prime equal look, f prime of x in the top, in the bottom 2 square root of f. You make it easy, simple. Example for this: y equal 3x squared plus 2x. Y prime equal 2 square root of 3x squared plus 2x, in the top 6x plus 2. Up. Then here we have u du. I just explained for you this 1 over 2. Why 1? Because derivative of x is 1 and derivative of 1 is 0. And this is dx. Solving for dx, 2 square root of x du. Okay, go here, leave 1 over square root of x, 1 over u, which is which one? All this, the one we consider as u here. And dx is what? Dx equal 2 square root of x du. That helps us to cancel which one? This guy. Okay, then the 2, we'll take the 2 as a constant outside. 2, 1 over u du. And you remember integration of 1 over u is ln u. 2 ln u plus what, guys? Plus what? Plus what? Plus c, always, don't forget, which is my final answer, 2 ln square root of x plus 1, right? Plus c. Okay, I have still time, right? This is easy, right? Now this is the same I meant to put for this definite. I'm going to leave it for you. This is indefinite integration and this definite integration. Since I have the last answer here from the step before, ln x to the 9, this guy the same as this, plus ln x. Now without cc we don't need it. From 1 to e squared. Plug the e squared, ln e squared to the 9 over 9 plus ln e squared minus ln 1 to the 9 over 9 plus ln 1. Ln 1, guys, equal to what ln 1, guys? Everyone knows ln 1 equal to 0. Ln 1 equal to 0. Okay. Here, what we have, this guy, 2 ln e. You see rules of exponent. Ln x to the n ln x. Remember this, guys. Remember, len x to the n and len x. And also remember that always I say len e equal what? Len e equal to 1. Now, how about the timing? We have time? Okay. Now, len e, how many minutes I have to finish?
2 minutes.
Okay, let me just finish 2 brown for these 2 minutes. Len e, 2 len e over 9 plus 2 len e. And minus 0, everything there is 0 because len 1 equal to 0. This is 1 and this is 1. 2 over 9 plus 2 over 1. 9 here. 2 plus 18 is 20. Okay. 6. Here, quickly, we need to finish this class to start with trig substitution and the integration when we have a power for sine and cosine. Another techniques. Now here's u equal 3x minus 2. Now everyone knows du equal 3 dx, then dx equal u. Okay, I'm going to show you something now for easy. You look here, dx equal du over 3. Now I can't change the limit. I'm going to show you another method because I don't want to say I'm going only in one way. Look here, guys. Everyone watch your hand. Watch. When x equal 1, right? When x equal 1, u equal what? 3 times 1. I'm going to do it. Minus 2, which is 3 minus 2, which is 1. Okay. When x equal, you can do this. I don't mind. When x equal 3, u equal 3 times 3, 9 minus 3 times 3, minus 2, 9 minus 2, 7. I have no problem. I have no problem to change from 1 to 7. 1 over u, and this is du over 3, the dx, from there. Now I can take 1/3 out. Integration of 1 to the u, 1 to the 7 du, which is 1/3 len u from 1 to 7, right? When it's easy to find the limit, in terms of u, I have no problem to do it. Equal 1/3 len 7 minus len 1. And you know, we just said len 1 equal what? 0. Then that's my len 7 over 3. Okay. Guys, thank you and have a nice day.